what we've got then, let's just recap. So we are solving simultaneous equations, or I prefer actually when it says finding simultaneous solutions. I know we've done this over and over again, but the whole point is that if we have two different functions, so function 1 and function 2, as we said before, if I put an x value in to each function, normally you would get different, so unique y values out. However, if we are finding simultaneous solutions, even though they're two different functions, when I put an x value in, the same one, they will give the same y value. Okay, so this would be the simultaneous solution. Okay, so we're finding when we've got two different functions, which value of x goes in to both functions to give the same value of y, instead of put a value of x in and get two different values of y. Now what we've already discussed is that how does that look like if we are drawing the graphs? Well, if we have function 1 and function 2, okay, so let's say that's function 1, this is function 2, the solution would be here, so the x and y values would be the coordinates of where the two lines cross. We've looked at that. So you can use your calculator to find that value if you want to, okay, which you do. However, there is algebraic methods. So we had the one where we were equating the two functions. So this is the first method we talked about. So for instance, we've got y equals 5x plus 2 as the first function, and y equals 3x minus 2 is the second function. What is the method? We're not going to go through the whole thing, but what's the first step? Yeah, it's kind of substitute, yeah, but what in this case it's nice and simple because all we have to do is, well, if y is the same, yeah, so we've just got therefore 5x plus 2. Well, if 5x plus 2 is equal to y and 3x minus 2 is equal to y and the y's are the same, we can say that 5x plus 2 has to equal 3x minus 2. Solve to find x. Do you want to do that? Subtract 3x. Okay. Yep.
So 2x equals negative 4. X equals 2. Negative 2.
So x equals negative 2. Now that is 1/2 of the solution. How do you find the y answer, the y value? Yeah, so I've got number 1 or number 2, whichever one you want to do. So I'm going to do, well, y is 3 times that answer minus 2 minus 2. Okay, so 3 times minus 2 is minus 6 minus 2, so y equals minus 8. So there's your second. Okay, so that was the first option. Then we changed things up a little bit and we did it through substitution. Okay, what was different about the questions?
They rearrange, like, instead of y to take an x.
So I've got y equals 3 plus x, but the second one will be 5x minus 2y equals 0. So yeah, one of them is now not in the form y equals, so we can't just put one's equal to the other. So this time, however, because we have y equals, we can use, because that's the same as y, so I can put that where my y is.
Yeah.
Okay? So I can then go 5x minus 2
3 plus x. Again, expand.
and then expand.
So 5x minus 6 plus 2x. Minus 2x. Equals 0. You've got x both sides.
Okay, can I simplify first? So 5x minus 2x is,
3x, then add 5.
now I'll add 6.
Oh yeah. 3x equals 6. 3x equals 3 divided by both sides. X equals 2. 6 divided
X equals 2. Good. Okay? And again, yeah, so finding the y value is easy peasy. So y equals, I'm going to use 3 plus 2, because this is the value. So y equals 5. So I've got my simultaneous solutions. Okay. 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 Right. So that's our substitution method. So we're now going to move on to solution by elimination. We've got our next option. All right. So you're ready. Okay. So you'll notice that there's again a change in the situation that we're given to start with. What is that change?
The x and the y are in the...
Go on, finish up. So the x and the y's are on the same side, which what we've had before is that, remember, here we had y equals, one of them was y equals. In our initial problem, they were both y equals. So you can see how we're being given different tools depending on what situation we're in. But you might look at that and say, well, I've already got enough tools to do what I need to. So could we use a substitution method, for instance? The answer is different?
No.
Well, what did a substitution method rely on us being able to do?
Having a y or an x have an equation.
Okay, so we needed a y equals or an x equals. Could we not set that up for ourselves?
Actually,
Yeah, we could.
It'd be minus x from both sides.
Well, I tell you, let's have a go at this using a method that we've already used, so the substitution method. So we want either y equals or x equals for one of them. So looking at equation number 1 or equation number 2, which one would you look at and think, oh, I'll make that one y equals or x equals?
2 and minus x from.
Why would you pick number 2? Yeah, spot. There's just one x. Remember, it can equally be x equals as y equals. So why don't we have a look at rearranging number 2? Right. So what would you get if we're going to rearrange number 2?
You add 3y y to both sides.
Yeah, we could definitely do that. So add 3y, so we end up with x equals 8 plus 3y. Okay. So I would offer a piece of advice here. When you're doing simultaneous solutions like this, you're going to have a lot of writing. And the more you try and take shortcuts and not write things down, the more confused you're going to make yourself. So I label them 1 and 2. Remember yesterday we talked about what happens if you substitute into the same one that you rearrange? Does it work?
Oh yeah.
Well, it works, but you get a piece of information that you already know. So what I'm going to do is I'm going to rewrite my 1 and 2. Now my number 1 hasn't changed. It's still 4x plus 3y equals 2. But my number 2 is now x equals 8 plus 3y. So what are we now going to do if we're going to do our previous method? Yeah?
Put the 8 plus 3y in the x position.
Yeah. So I'm going to replace the x here with that 8 plus 3. Right. So we can now rewrite my number 1 with the substitution as 4 lots of
8 plus 3y equals 2.
not yet, because that's just that bit,
Oh, plus 3.
plus 3y again, and that equals 2. Okay. So this looks like it's working out okay, yeah? Talk me through it then.
So then you do 32
32
plus 3y equals 2. And 32 plus 50y equals 2. Here. And then you subtract 32.
good. Minus 32 gives me 15y equals, careful, 2 subtract 32, negative 30.
Yeah, 50. Yeah.
What'd you say?
Y equals negative 35 by 50.
Divide by 15, which leaves us with
Y equals negative 2.
negative 2. And then to finish us off, we've still got to find x. So we've actually now got lots of options. So we can use this one, or this one. And actually, because we've rearranged one to say x equals, would it not make sense to say, well, I want x, so I'm going to say x equals 8 plus 3 times negative 2. So x equals 8
Plus negative 6.
minus 6.
So
So that is our simultaneous solution. So you already have a method that would work. Substitution method. We've got an answer. Are you happy with your answer? How would you check that those values work?
into the first equation. So 1
Okay, yeah, so we could put them into here and just check they work. Yeah. Right. What we do want to be able to do though, this is about solving through elimination. So we have another method. But just to show you that you don't need to use a particular method, they're just offering you different ways. So we're in this situation where we would need to rearrange if we were going to use substitution method. All right. So just keep it a sec while I let's restart it. but we're going to use an elimination method. So, when you have done your substitution method, when you have done your equating the two sides, what has happened at every stage? What have you had to kind of do? Kind of had to get rid of one of the letters, yeah? So either you get rid of the y's, or you replace the x with something with y in it. Okay, so the only way to solve these is to actually reduce it so that we only have one letter that we don't know. So when we have an elimination method, we're looking at a different way of getting rid of one of those letters, one of those variables. Now, what I can do here is I've spotted that for my y variable, I have the same number of y's. Okay, so I have positive 3 y's and I have negative 3 y's. Now this elimination method approach, what you have to do, there are two ways to consider it. Well, we can say cancel each other out, but what I would prefer to get you into thinking is we've got an option. We either add the two equations together or we subtract the two equations. Another method is to think, oh, we always try and make the signs different and then we always add. But do you know what that leads? I think that's a bit of a shortcut. It relies on us remembering a particular, well, do I make the signs the same or different? Or so if we can actually understand the principle is we're either adding them or we're subtracting them, we've got either or, then a change in situation is not going to phase us at all. What we're looking at is after adding or subtracting, we end up eliminating one of those variables. So I'm looking at it and thinking, well, I've got 3 and 3. Okay, so I'm either going to look at adding them or subtracting them. And I'm going to focus on this to make my mind up. So what I'm looking for is, do I do positive 3y add negative 3y, or am I going to do positive 3y subtract negative 3y? Right? And what I'm looking for, because I've got to do the same to all of them, each part, I've got to do it to this part, and this part, and I'm going to add or subtract. I need either the x's to become nothing or the y's to become nothing. Okay, I've picked the y's because I have 3 and 3, so 3 and 3 would make 0 if I were to subtract. But I've got positive 3 and negative 3. So which one would it be? So positive 3y add negative 3y would make
0. I thought it was 0. Yes.
Or we need to get this right. We need to make sure that you're very happy with this. So what if I, do you remember that the 3 is a coefficient, it's how many y's we have. So what if I were to say, well, let's forget the y even exists for the time being. So plus 3, so I'm at 3, if you want to use the number line up behind you, you can. I'm at plus 3, and then I add negative 3. What techniques do you have for doing that? So what's 3 add negative 3? 0. What's 3 subtract negative 3? 6. Okay, so you remember subtracting a negative, actually, if you subtract a negative, it's like doing adding. If you add a negative, it's the same as doing subtracting. Okay, remember doing that from before? So if I put my y's back in, I just do the same to the answer. Now 0y is the same as just 0. Okay, so I can actually forget about my y there. So which one do I choose to do? Do I add my two sets of equations, or do I subtract them? I'm going to add them. So I'm going to do, that's made my decision, I'm going to add them all together, right? So I'm going to now do, and I would do this in an exam, I would be writing out my working, I've labelled them 1 and 2, and I would go, I'm going to do 1 add 2. So 4x add x is 5x's. I know that plus 3y add minus 3y is 0, so I can forget about that. 2 add 8 is 10. So I've now gone from my 2, so I've now got 5x equals 10, so x has to equal 2. Does that agree with what we had before? Just check up here. Yep. We're happy with that. How do we find y? So the same way that we've done it every time before. The second one is always the same. Okay. Does that make sense? Any particular questions? Now, obviously, we'll change. Situations will change. But what I'll get you to do first, let's have a bit of practice first. So if you have a look at page 163. Okay. So it says which variable to eliminate first. Okay. Do you remember why I told you I was going to eliminate the y in this case? Why was it? Because they have the same number, so that was my choice. Then I have to decide if I add or subtract. So, having a look at exercise 70.3, page 163. Okay. I would like you to, first off, I don't want you to just do the questions. I would like you to identify any of those from questions 1 through to 5. Any questions where you think it will be the x that I eliminate first. Can you find a question like that? And tell me why. The y that you would eliminate first. And I would like you to find examples of when I would add or when I would subtract. Can you do that for me first? So 5 minutes. So looking through that whole set of questions, 1, 2, 3, 4, 5. I would like you to pick out like 4D. I would eliminate x first, and I would do it by subtracting. If that's where you left it. And then after we've identified that, we'll get you to do them. So, looking at these questions then, which examples have you found where you would eliminate x first? No? 1e. What do you reckon? Everyone? You all agree? And the reason is because the x is the same. The coefficient for x is close to 7. Okay. Is that it? 1b. Sorry? 1b. 1b? Yeah, same idea. Okay. F. Okay. What about the eliminating the y? 2a. 1a as well, I think. Julian said, yeah. So basically then, the one that you're looking to eliminate, you're looking for the coefficient to be the same number. There's no secret to it really, if it's the same number. What about examples of where you would, so we added, what about where you would add? So 1a. Do we agree 1a? Yeah. 2a, you would add 1e. There's a bit of a discussion there. Do we add or not for e? And if we were going to add for 1a, why wouldn't we add for 1e? What would be your reason? Say it again. No, go on, I think you've got the right idea. It's something to do with the negative number. Yeah. So do you think it makes a difference if the top number is negative and the bottom is positive as to whether you add or subtract? Or?
No, don't you add all of them?
Do we add all of them? Well, there's a good question then. So that's what we were looking at. How do we know when to add and when actually we would subtract? Well, let me have a. If you have a look to the top and bottom of different. There you go. Different signs. If one of them is positive and one of them is negative, you're going to add. Because you've got to eliminate, so we're going to add. If the two signs were the same, you'd imagine to subtract. Now, I would like you to have a look at 2b. What do you think about 2b? What does that? Okay. So if I just got a question for you, 2b, right? Which is 3x minus 2y equals 7, and then 3x plus 2y equals minus 1. Okay. So what do you notice about that one? Yeah, the x's are the same, the y's are the same. Okay. So I could choose to eliminate the x's or the y's in this way. Right? But if I wanted to eliminate the y's, would I add or subtract?
Subtract. I think it's
Well, I'll tell you what, there's a lot of discussion there. Why don't you have a go? Why don't you do it? You try either adding or subtracting, and you choose which one. So, but what I would like to do in your head, I want you to think, this is what I'm expecting to happen, and see whether that is what happens. So if you want to add them, do it. If you think subtracting is the right idea, do it, and see what we come out. Okay. So if we have a look, first of all, we want to identify which variable we want to eliminate. Which one do you choose? Y. Okay. So you're choosing to eliminate the y. Fair choice. How are you going to eliminate? What do? Do you add or subtract? So we're adding. We've got different signs, so we're going to add. So again, we're going to write down 2 add 1. So I'm going to add those two. So 3x add 3x is 6x. That becomes 0. 7 add minus 1 becomes 6. Okay? So we've got x equals 1. Okay? If we then substitute that value in, whichever one you want, so 3 times 1 minus 2y equals 7. So I'm using number 1. So that's 3 minus 2y equals 7. So minus 3 from each side, okay. So this is minus 2y equals 4. Divide by negative. Are you all spotting where you've made mistakes?
Yeah. I just forgot how to find it. I substituted y, so
Yeah, you've got to be careful actually, that's a common mistake. So we've got y equals 4 divided by -2 is -2. Okay, so we've got our two solutions, right? So the colours are not coming out so well, are they? What I would just like to show you though is what if we'd have decided to go for x instead. Alright, so I'll rewrite it. So 3x minus 2y, 7 to 3x plus 2y. Now obviously, even if I do it differently, I should end up with the same solution. Right? If I don't, something's wrong. But what we can equally eliminate the x's because they're the same as well. Right? But this time, because it's 3x and 3x, we're going to subtract. Now, which way do you want to subtract? Do you want to subtract 2 from 1 or 1 from 2? Doesn't matter, but you choose based on what makes it easier for you.
1 from 2.
Well, I've got both options chosen. What's the reason?
Because 2 from 2 minus 2.
One from 2 or 2 from 1?
1 from 2.
1 from 2. So I'm going to do, remember normally we would do, you know, the way you do it is you do the bottom one take, so bear in mind, because we're not rewriting it, remember which way we're going to do it. So I'm going to do 2 take away 1. So notice how I'm writing this out every time. So 3x, subtract 3x, it's gone. That's all right. So then I've got positive 2y, subtract negative 2y.
4y.
4y. So positive 2y, subtract negative 2y, makes 4y. So we've actually got 4y there. And then we've got minus 1, negative 1, subtract 7. Subtract 7, minus 8. So that's why it's important that you keep in your mind which way you're doing it, which is why I write it. 2 subtract 1, minus 1 subtract 7. So now we end up with, well, we've got 4y is minus 8, so therefore y must be -2, which we've got. Okay. So the reason why I wanted to do that one, you can see now how, depending on whether you've got the signs different or the signs the same, these could both be considered positives. We can add or we can subtract. We could choose to do x first, we could choose to do y first. Doesn't matter.
There's one bit that you did on the other page.
Okay, yeah.
Or that bit, by being no y. Does it matter what equation you use to find it?
No, because they both should hold true. They should both give you, the x and the y should work for both. Okay.
Are you able to print the first page that we did today?
The what, sorry?
The first page, like with the objective and stuff on it?
I'm sure I can have a look at it. Or I can just send it to you. It's on the video. So, tell you what, while we have a look at that, before we look at question 4 then, why don't you carry on? I asked you to do 1 more, 2 more from questions 1, 2 and 3. Pick a different one from the person next to you to have a practice, just to check that you understand. And then we'll, in 10 minutes time, we'll just have a quick talk about question 4. Right, excuse me. Right, so we've got this one, a different set of equations. I'm still going to do number them 1 and 2. Sorry, that should be a subtract, should be in the middle. Right, but you did point this one out, question 4, as being a bit different. It's different. Why? What did you spot?
None of them
None of them are the same.
And some of them just rearrange it.
Well, the ones that don't have numbers, let's say, is not a problem because if there's no number, it's just a 1. Yeah, so we just treat it like a 1. But yeah, the problem is that none of them are the same. But we can sort that out. Okay?
Can we rearrange?
We could rearrange, like you said, we could make it x equals or y equals, but we're going to stick with our elimination method. So this is probably the point at which in an exam you are going to be expected to have to do one like this. Okay? So basically, what we have to do is, although none of them are the same, we can change it so that one is the same. Okay? And we've got a choice. So we can multiply through. So for instance, I know that if 2x's plus 1y is 8, what if I were to double the whole thing? Could I say 4x's plus 2y's equal 16? Does that make sense? Okay, well, so I could multiply by 2, by 2, by 2. Now, before you write that down, that doesn't actually help me at the moment because it still doesn't do anything. So let's not, okay, yeah, let's not do it to that top one. Let's do it to the second one. So let's multiply this one by 2. So we multiply by 2, multiply by 2, multiply by 2. So that would then give me, number 1 is still 2x plus y is 8. But my new number 2 is now what?
2x plus 6y. No,
Minus.
Equals 22.
Okay. Alright. Now, that's one option. I could equally have done what? So that's lining up my x's. That's making my x's the same. And what would you do? Add or subtract now? Subtract. So I'm going to do 2 subtract 1 just because of the 22 minus 8. Okay. Equally though, if I hadn't wanted to do the second one by 2, exactly, I could have multiplied the first one by 3 and ended up with 6x, so instead of that I could have multiplied this one by 3, 6x plus 3y equals 24, and number 2 would have stayed the same, x minus 3y equals 11, and then would have added or subtracted. Added, so other than to add. Either way. Yes, yes.
Is there like a general rule that if the number you're trying to reduce equals 0, if they're both positive and they're both negative, that you need to subtract them?
Well, I guess.
I mean,
No, I do know, and it's a very good question. I don't know why it's sniggering, but
it is.
if the signs are the same on the one that you're trying to eliminate, you would add them.
Like always?
Always. If the signs are different, you would subtract them. Yeah? Right? Because if you add two things that are the same, you will get double it. But if you add the opposites, you'll end up with nothing. So. But in this case, we've got either or, whichever option. So this one was number 1 times 3. This one was number 2 times 2. So you've got either option. And then you carry on from there, whatever you choose to do. But what we have to do is multiply to make one of them the same. That's basically the principle behind it. Does that make sense?
Yep.
Okay. So just for any questions?
I have a question.
Yeah.
Could you have just subtracted 2?
No.
You can't.
We can't subtract. It's either multiply.
So you got your 2 from your first number and I have the expression 1.
So Yeah, because I wanted, I've got 2x or x.
I think that's
Right,
a
that's
break
not
cut.
quite right.